Welcome back. In this video, we will have an introduction to circular linked list with an example. You already have an idea about this single linked list and how it works and how to write program to insert, delete and modify the nodes in a single linked list. In a conventional linked list like this, look at the last node. In this last node at 291, the next pointer is pointing to null. Now, if we write here 743, which is the address of the first node, then this null link vanishes and a link to the first node will be established. And this is singly circular linked list. The only difference between the conventional linked list and circular linked list is that the last node here will be pointing back to the first node. Now look at the doubly linked list here. Now in this doubly linked list, you have prev pointer as well as next pointer. So here at the last node at 291, you see the next pointer is pointing to null. And in the first node, you see that the prev pointer is pointing to null. Now, if you change this null pointer here with 743, then this will point back to the first node. And here, if you replace this null pointer with 291, the address of the last node, then this will be pointing to the last node. So you have got doubly circular linked list. Now let us see what kind of application this circular linked list can give us. There is an algorithm called round robin algorithm, and the idea is something like this. You take this example. So there is a server and these are the clients. Client 1 is here, client 2 is here, 3 is here and 4 is here, right? Now a single server can serve only one client at a certain moment. For example, you have the mail server here. There is only one mail server and 4 users from 4 different machines have connected to this server to check their inboxes. Now, how this mail server will serve the 4 users here at a time? So it is not possible. So what the mail server will do, it will serve the first any one of the clients, say client 4, for a small interval of time. Then it will go and serve to client 1 for a very small interval of time. Then it will serve the client 2 and then it will serve the client 3 and again back to the client 4. Now the thing is that the server does this job so fast that each of the clients think that the server is only serving his machine. But actually it's not. The server changes the service from client 4 to client 1 to client 2 to client 3, again back to client 4 so fast that it appears that it is actually serving all the clients at a time. So this is the idea of round robin algorithm. Now let us see here how it can be applied. Suppose the client 4 is having an address, a machine address 53, and client 1 is having address 78. These are all machine addresses, okay? Now you see here, these are the 4 clients, client 1, 2, 3 and 4. And what the server has done, the server has created a linked list. And it has created 4 nodes. Now you can see that the server has created a doubly circular linked list. You can see that. The last node is pointing to the first node and vice versa. Now what is there inside the node? See, in the first node at 743, where the start is pointing to, 78 has been written. So what is 78? 78 is actually the starting address of client 1. Similarly, in the node 2 at 478, 29 has been written. So what is 29? It is the address of client 2. And in the third node and the fourth node, the addresses of the client 3 and 4 have been written. Now see the code. Temp equal to star. When you write this, the 743 will be written here and the temp will start pointing to the node at 743, which is the first node in this circular doubly linked list. Next, while required job is not over, there may be some condition here based on which whatever the job to these clients will be done, so that will be checked. And it will be checked that whether the job for client 4 or client 1 or client 2 or client 3 has been over or not. If the required job is not over, then you load this MAC underscore address variable with the temp data. Now you see that temp is pointing to 743, which is the first node, and the temp data means 78. So this will be 78. So this MAC address will be loaded with 78. Now this is really not the MAC address what you are familiar with. This is just a variable name I have taken. I actually meant to say that this is a machine address. So it may be MAC address, it may be IP address, whatever the algorithm will support, you do that. But this is just a variable I have taken to indicate that we are dealing with the address of the machines. Okay. So this MAC address will be loaded with 78 and the required job will be done. Because the 78 is the address of the machine, so you visit that machine and do the job, whether the user is checking his inbox or whether the user is writing some email, like that, whatever the job may be. So you serve the machine for a small interval of time and then you go to the next node, that is temp equal to temp next. Now what is temp next? The temp next is 478, right? You see here, this is 478. So that will be loaded inside temp. So temp becomes 478 and it starts pointing to the next node. Now after moving to the next node, you get back to run the while loop and check whether the required job is over or not. So if it is not, then get inside and repeat the previous steps. You load this 29 inside this MAC address. Then you visit the MAC address, that is 29, that with this client. You serve the client whatever the client wants. Then you apply temp equal to temp next. Now what will be the temp next? It will be 521. See? So this temp will be loaded with 521 and it will start pointing to the third node. After this, you get back and check whether the job at 521 is over or not. If it is not, then get inside, load the MAC address with the temp data. The temp data is 89. So you load this 89 here and visit that MAC address, this one, and do the necessary job there. After a small interval of time, you come back and update temp equal to temp next. Now the temp next is 291. So this will be loaded inside temp. So it becomes 291 now and it starts pointing to the address at 291, which is holding the address of client 4. So you take this thing, that is 53 temp data, you load it inside MAC address variable, you go and visit MAC address, this one, and do the necessary job there. After a small interval of time, you come back to update this temp variable or the temp pointer. Of course, pointer is a type of variable. So, what will be the temp next? You see the temp next is 743, which is the address of the first node. And that node is holding the address of the client 1. So, you write here 743. So, 743 has been written here. And it starts again pointing to the first node to check the address, the machine address 78. So it goes on like this in a circular manner until some job in some client will be over, right? Now you may ask me that it may happen that client, suppose in client 3, the job here is over. So that means it does not need the service of this mail server. But still, this client 4, client 1 and client 2, they need the service because their jobs are not over. Then how will the linked list will look like? Yes, you have learned how to delete node from a linked list. If you missed those videos, please see those videos and you will find out how to delete a node from a linked list, both in single linked list or in double linked list. So suppose the client 3, this 89, this node is out of this list because its job is over. So you have to delete this one. So if you delete this one, then this link will be directly connected to this one at 291, and the node 291 will have a preb pointer to this, and this node will be pulled out of this list. So you have learned how to delete and pull out the nodes from a singly and doubly linked list. The same technique applies here. Now, one small question here, that suppose your singly circular linked list carries one node only. So this will be the scenario, and the start is pointing to the 743, and suppose 78 is there as a data. This is actually immaterial now. Now what will be the content here in the next pointer part? Whether it will be null or it will be 743. Because since it's a circular linked list, the last node should not be null. So of course, null will be not there. the 743 will be there, and when you write 743, it will point back to itself. Okay? So in case of doubly circular linked list, the next pointer will point back to itself, and the prem pointer also will point back to itself. So this is the small thing I had to mention, because people used to ask like that in case of a single node, whether it will be a null there or not. So it should not be null because it's a circular, so it will point back to itself. But there is no harm. So I hope you have a clear idea about a circular linked list and how it works in real life application. So in the next video, we will learn how to insert a node in the first position in a circular linked list. Thank you for watching and take care.